The other thing is, give a cocktail, a combination of different drugs. Make sure that you get them. Here's an example of synergistic effects. You got a zone of inhibition around this disc, you got a zone of inhibition around this disc. But in the middle, the two drugs enhance each other's effect. So the bacteria can't grow in the middle either. You might see that on your Petri plates. Use antibiotics only when necessary. Develop new kinds of drugs. If you're into it, when I was a pharmaceutical rep, we had to study first generation, second generation, third generation drugs. That means they take it back into the lab, they biochemically alter it, they come back with a drug that has a slightly different way of acting that's better than the drug that preceded it. And there you can read this chart in your book. When you go to look at the different antibiotics we're going to use in lab, that chart, they don't give me a copy of it to show you in the PowerPoint, you have to go to your book. But it's several pages long, that chart. It's got antibacterial antibiotics, it's got antiviral drugs, antifungal drugs, antihelminthic, that means against parasitic worms, and antiprotozoals, like what drugs are used for malaria, for example. So it's got a lot of that in there. Okie dokie. Let me just see. What's the therapeutic index? Therapeutic index. Sometimes the doctor will call it a therapeutic range or a therapeutic window. The therapeutic index is the ratio of tolerable dose to effective dose. Tolerable dose to effective dose. If the effective dose is 10 micrograms, but the tolerable dose is 8 micrograms, I think you'd be looking for a different drug. If the tolerable dose is 20 micrograms, and the effective dose is 10 micrograms, okay, now we can probably use that. That's worthwhile. So therapeutic index is tolerable dose over effective dose. Okay. I think for your exam, penicillin, cephalosporins, bacitracin, vancomycin, those are going to inhibit cell wall. Inhibit cell wall synthesis, or inhibit the peptidoglycan. Penicillin and cephalosporins, and if you want to generalize the others, they're beta-lactam antibiotics. Penicillin, cephalosporins, vancomycin, bacitracin target peptidoglycan, inhibit cell wall synthesis or damage the cell wall, and beta-lactam antibiotics is this category. They have the beta-lactam ring. Then you have polymyxin, and that disrupts plasma membrane, particularly for gram-negative bacteria. Polymyxin disrupts gram-negative plasma membrane. Remember, clotrimazole, imidazoles, those are antifungals. Antifungals are imidazoles. And they also target plasma membrane, but are fungi. Not be so lazy to get off my butt. I don't want to spend a lot of time on it, but all right. Tetracycline and aminoglycosides. You'll see all these when you look. Tetracycline, doxycycline, they're all in that category. Inhibit ribosomes. There's other ones that also inhibit ribosomes. Some inhibit one subunit and others inhibit the other subunit. Sulfa drug, sulfonamide, sulfanilamide, any sulfur drug with sulfur in it. Is a competitive enzyme inhibitor. Then you got your base analog drugs. Base analog drugs. Base analog drugs interfere with nucleic acid synthesis, interfere with DNA and RNA manufacture. A lot of antivirals are base analogs. Also, quinolones, rifampin, and actinomycin. Where do you think actinomycin comes from?
Soil.
Comes from actinomycetes bacteria. Remember actinomycetes, they're bacteria that they thought were molds, that's why it's got the mycin in the name?
So those are base analogs, all of those?
Yes. Rifampin. Rifampin is used for tuberculosis. And quinolones. Probably don't have to memorize those. Remember this. Antivirals can be base analogs. When we review for the test, I'll tell you which specific ones you need to remember. When you go into the nursing program, then you'll have to remember them all. Have you seen the book for the pharmacology class yet?
Horrible.
I used to teach pharmacology at East West College of Natural Medicine.
I would feel that.
Because usually when a person goes for acupuncture or something like that, it's usually a last resort, right? You go to the doctor tries to help you, gives you 10 million different medicines, you still feel miserable, you finally resort to going for acupuncture or something like that. Or herbology. So you have to be careful, because if you give certain herbal medications, or even acupuncture, depending on what the patient's condition is, you know, it might interact with drugs they're already taking. So even if you study Eastern medicine, you still have to know Western medicine, so you don't give the patient a conflict to drugs or to agents that are contraindicated. I think that's the one works. Okay. Let's go over a couple things you will need to know. Allergies. You might be allergic to an antibiotic. Why? Because it's made from mold. If you're allergic to molds, you're probably going to be allergic to antibiotics that are made from molds, like penicillins. You could go into anaphylactic shock if it's a really bad reaction. Anaphylactic shock is an extreme allergic reaction. Sulfur, any drug that contains sulfur. If you're allergic to sulfur, you're going to be allergic to sulfanilamide and sulfonamide and any drugs that contain sulfur. Those are probably the two most common drug allergies I can think of when it comes to antibiotics. What one? Psyllins? All the psyllins, like penicillin, piperacillin, methicillin, because they're all related to penicillin. And let's review also other reasons for side effects. So one side effect is allergies. That's an allergic reaction to the drug. Another reason for side effects, remember, is you disrupt the balance of normal flora. You disrupt the balance of normal flora, it could result in opportunistic infections. Sometimes it could result in an opportunity for a secondary infection, which could be called a superinfection. Two examples of disruption of normal flora as a side effect from antibiotic therapy is overgrowth of Candida albicans. So you get oral thrush, you get yeast infections on your skin and your vagina. You can even get them in your digestive tract. Also, another reason, another example of disruption of normal flora results in C. diff. Remember Clostridium difficile? If you have killed off a lot of your normal flora with antibiotics, and the Clostridium difficile that you carry in your bowels, endospores all germinate, you're going to have mostly C. diff and nothing else. And that can result in a condition called pseudomembranous PSEU, pardon me. I don't like this marker today. PSEU, pseudomembranous, which means a false membrane. Pseudomembranous colitis. Your colon is very inflamed. You actually have a sheet of dead cells in there. In your colon. The diarrhea is really severe because Clostridium difficile